Okay, we were discussing about Planck's postulates. I was repeating about. I will repeat about two Planck's postulates. So the first one is a black body is consisting of atomic oscillators capable of vibrating with all possible frequencies. An oscillator of frequency nu can have discrete value of energy given by E is equal to nh nu, and that is what your quantum theory. Okay, so in the black body there are oscillators, and when these oscillators oscillate, so either they are going to emit quantum or observe for quantum. Okay, and they can undergo vibration with all possible frequencies. Okay, and if they are vibrating with a frequency nu, so then the energy associated with these black body atomic oscillators are given by E is equal to nh nu. The second postulate is an atomic oscillator can emit or absorb energy in discrete set of energies nh nu. Okay, so an atomic oscillator cannot emit, cannot absorb radiation in a continuous way. It can absorb or it can emit energy only in sets of packets of energy. Okay, discrete set of energies, packets of energies are quantum, and the energy of the quantum is nh nu. So I have already told this so many number of times. Okay, so based on these two postulates, let us discuss. So Planck's law, Planck's radiation law, which successfully explains the distribution of energy in the black body spectrum. Okay, ಸ್ವಲ್ಪ mathematics ಇದೆ, ಸ್ವಲ್ಪ careful ಆಗಿ follow ಮಾಡಿ. Using Boltzmann distribution law, so I'm going to handle another unit that is what we call it as I'm going to handle another unit that is what we call as statistical mechanics. In statistical mechanics, we shall discuss about this Boltzmann distribution law. Anyhow, I am directly making use of this Boltzmann distribution law. Okay, so the number of oscillators with energies I have told. So the black body is consisting of oscillators. Oscillators are having different energies. Okay, and the number of oscillators with energy is 0. Energy of the oscillator is nh nu. N can be either 0, 1, 2, 3, etc. etc. If you substitute 0, energy 0 ಆಗುತ್ತೆ. If you substitute n is equal to 1, energy h nu ಆಗುತ್ತೆ. If you substitute n is equal to 2, h nu ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಕೆಲವೊಂದು ಆಸಿಲೇಟರ್ಸ್ ಎನರ್ಜಿ 0 ಇರುತ್ತೆ, ಕೆಲವೊಂದು ಆಸಿಲೇಟರ್ಸ್ ಎನರ್ಜಿ h nu ಇರುತ್ತೆ, ಕೆಲವೊಂದು ಆಸಿಲೇಟರ್ಸ್ ಎನರ್ಜಿ 2h nu ಇರುತ್ತೆ. ಓಕೆ, ಅಂಡ್ ಸೋ ಆನ್, ಅದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ದ ನಂಬರ್ ಆಫ್ ಆಸಿಲೇಟರ್ಸ್ ವಿತ್ 0 ಎನರ್ಜಿ ಈಸ್ n0. Okay, n0 is the number of oscillators. Please follow very carefully this particular sentence. n0 is the number of oscillators with 0 energy. n0 into exponential minus h nu by kt is the number of oscillators with energy h nu. n0 into exponential minus 2 h nu by kt is the number of oscillators with energy 2h nu. Okay, ಇಲ್ಲಿ exponential function ಎಲ್ಲ ಯಾಕೆ ಬಂತು ಅಂತಂದ್ರೆ ನಾವು ಬೋಲ್ಟ್ಸ್ಮನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಲಾ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಬೋಲ್ಟ್ಸ್ಮನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಲಾ ಇನ್ನೂ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ಕೊಟ್ಟಿಲ್ಲ, ನಾನೇ ಮಾಡ್ತಿರೋ ಪೇಪರ್ ನಲ್ಲಿ ಫಸ್ಟ್ ಯೂನಿಟ್ ಅಂತ ಇದೆ ನೋಡಿ, ಈ ಫಸ್ಟ್ ಯೂನಿಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, ಅದು ನಾವೇ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಬಟ್ ಏನೇಹೋ ಅಲ್ಲಿರೋ ರಿಸಲ್ಟ್ ನಾನು ಇವಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಓಕೆ, ಸೊ n0 is the number of oscillators with 0 energy. n0 into exponential minus h nu by kt is the number of oscillators with energy h nu. n0 into exponential minus 2 h nu by kt is the number of oscillators with energy 2h nu, and so on. n0 into exponential minus 3h nu by kt is the number of oscillators with energy 3h nu, and so on. Okay, so therefore we want to find out an expression for the total number of oscillators. So total number of oscillators ಇಲ್ಲಿ n0 into ಆಮೇಲೆ n0 into exponential minus h nu by kt, n0 into exponential minus 2h nu by kt ಇದೆಲ್ಲ ಎಲ್ಲ ಟರ್ಮ್ಸ್ ನು ಆಡ್ ಮಾಡಿಬಿಟ್ರೆ ಆಗೋಯ್ತು. ಓಕೆ, ನಮಗೆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಆಸಿಲೇಟರ್ಸ್ ಸಿಗುತ್ತೆ. ಸೊ ದಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದಿ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಆಸಿಲೇಟರ್ಸ್ ಈಸ್ n is equal to n0 plus n0 into exponential minus h nu by kt plus n0 into exponential minus 2h nu by kt plus n0 into exponential minus 3h nu by kt, and so on. ಇದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದಕ್ಕೆ h nu by kt ನ I have taken it as alpha. So therefore if we take h nu by kt as alpha, so n becomes equal to n0 plus n0 into e power minus alpha, n0 into exponential minus 2 alpha plus n0 into exponential minus 3 alpha. ಹೌದಾ, ಸರಿ ಇದೆಯಾ?
Yes sir.
I think it is correct. I think it's not correct. I mean, it is not. I am saying it is correct. I think you are following this. Okay. So number of, I am just counting the total number of atomic oscillators in the black body. Okay. So therefore, so I am doing all this mathematics. Okay, so if I take n naught outside, n naught nache tagonbitre, so n becomes equal to n naught 1 plus exponential minus alpha plus exponential minus 2 alpha plus exponential minus 3 alpha and so on. Okay, so this is equation 5. So there is a series, either exponential series, exponential series na ನೀವು so mathematics ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಓದಿದ್ದೀರಾ. ಅದು ಒಂದು ರಿಸಲ್ಟ್ ನ ನಾನು ಯೂಸ್ ಮಾಡ್ಕೊತಾ ಇದ್ದೀನಿ. 1 plus exponential 1 plus e power minus alpha plus e power minus 2 alpha and so on. ಇದಿಷ್ಟನ್ನು ಸಮ್ ಮಾಡಿದ್ರೆ you are going to get 1 divided by 1 minus exponential minus alpha. Okay, so this summation 1 plus e power minus alpha plus e power minus 2 alpha and so on is equal to 1 divided by 1 minus exponential minus alpha. Okay, so ಈ expression ನ ತಗೊಂಡು ಹೋಗಿ equation final substitute ಮಾಡ್ತೀನಿ. Final substitute ಮಾಡಿದ್ರೆ I am going to get n is equal to n naught divided by 1 into 1 minus exponential minus alpha ಆಗುತ್ತೆ. Or I can write n by n naught is equal to 1 divided by 1 minus e power minus alpha. Or the reciprocal ತಗೊಂಡ್ರೆ n naught by n is equal to 1 minus exponential minus alpha. So this is equation 6. Okay, we are able to derive an expression for the total number of oscillators. Total number of oscillators n is equal to given by n naught divided by 1 minus e power minus alpha, where n naught is the total number of oscillators with the energy is 0 and alpha is h nu by kt ಆಗುತ್ತೆ. So therefore, with the help of this expression, I have got n naught by n is equal to 1 minus exponential minus alpha. ಹೌದಾ? ಫಾಲೋ ಮಾಡಿದ್ರೆ equation 6 ತನಕ?
Yes sir.
Others?
Yes, sir.
Yes
Okay.
sir.
Now we have found out the total number of oscillators. We want not only total number of oscillators, we also want total energy of all the oscillators. Okay, so therefore total energy of all the oscillators ತುಂಬಾ simple ಇದೆ ನೋಡಿ. E, capital E is the energy of all the oscillators ಅಥವಾ total energy of all the oscillators. It is given by 0, energy 0. ಯಾವುದಕ್ಕೆ energy 0? n is equal to 0 ಹಾಕಿದ್ರೆ NH ಒಳಗಡೆ 0 ಬರುತ್ತೆ. So number of oscillators n naught are having energy 0. So therefore the total energy of n naught oscillators with energy 0 is 0 into n naught ಆಗುತ್ತೆ. Okay, and then we have, so next possible value n is equal to 1. n is equal to 1 ಹಾಕೊಂಡ್ರೆ energy becomes nh nu means 1 h nu ಆಗುತ್ತೆ. So it is h nu into number of oscillators is nothing but n naught into e power minus alpha. ಅದನ್ನ previous step ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ, n naught into e power minus alpha. So therefore the total energy of oscillators with the energy h nu is h nu into n naught e power minus alpha. And if you go to the next one, n is equal to 2 substitute ಮಾಡಿದ್ರೆ the total energy is 2 h nu and the such number of oscillators is nothing but n naught into e power minus 2 alpha and so on. And we have next term 3 h nu into n naught exponential minus 3 alpha and plus so on. Continue ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಈ ಸ್ಟೆಪ್ ಫಾಲೋ ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes sir.
Okay, and then afterwards if you simplify, ಇದನ್ನ simplify ಮಾಡ್ಕೊಂಡ್ರೆ ನೋಡಿ, ಫಸ್ಟ್ ಟರ್ಮ್ 0 ಆಯ್ತು ಬಿಡಿ, ವ್ಯಾನಿಶ್ ಆಯ್ತು, ಹೊರಟೋಯ್ತು. ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಒಳಗಡೆ ನೀವು ಅಥವಾ ಸೆಕೆಂಡ್ ಮತ್ತೆ ಥರ್ಡ್ ಟರ್ಮ್ ಆನ್ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ನೀವು h nu ಮತ್ತೆ n naught e power minus alpha ಕಾಮನ್ ತೆಗಿಬಹುದು. So therefore h nu n naught e power minus alpha. So ಉಳ್ಕೊಳ್ಳೋದು ಫಸ್ಟ್ ಪ್ಲಸ್ 1 ಉಳ್ಕೊಳ್ಳುತ್ತೆ, ಬಿಕಾಸ್ ಈ ಟರ್ಮ್ ಅಲ್ಲಿ ಎಲ್ಲ ಆಚೆ ತಗೊಂಡಿದ್ರೆ 1 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಅಲ್ಲಿ ಸೊ h nu ಆಚೆ ಬಂದಿದೆ, ಹಾಗಾಗಿ 2 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. n naught ಕೂಡ ಆಚೆ ಬಂದಿದೆ, n naught ಇಲ್ಲಿ ಬರ್ದಿಲ್ಲ, ಆಚೆನೇ ಇದೆ. ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಮೈನಸ್ ಆಲ್ಫಾ ಮಾತ್ರ ಕಾಮನ್ ತಗೊಂಡಿದ್ದೀನಿ, ಬಟ್ ಇಲ್ಲಿ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಮೈನಸ್ 2 ಆಲ್ಫಾ ಇದೆ. ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಮೈನಸ್ 2 ಆಲ್ಫಾ ಒಳಗಡೆ ಒಂದು ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಮೈನಸ್ ಆಲ್ಫಾ ತಗೊಂಡ್ರೆ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ 2 into ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಮೈನಸ್ ಆಲ್ಫಾ. Similarly third term 3 h nu into n naught into exponential minus 3 alpha ಬರುತ್ತೆ. So h nu ಆಚೆ ಬಂದಿದೆ, ಹಾಗಾಗಿ 3 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. n naught ಕೂಡ ಆಚೆ ಬಂದಿದೆ, exponential minus 3 lambda, sorry 3 alpha ಇದೆ. 3 alpha ದಲ್ಲಿ exponential 1 alpha ನ ಆಚೆ ತಗೋತಾ ಇದ್ರೆ, ಹಾಗಾಗಿ you are going to end up with 3 into exponential minus 2 alpha. So this is equation 7. So I think you are following this step also. I have simply taken h nu n naught e power minus alpha, and the remaining terms I have written inside the bracket. And equation 7, what I am going to do is, equation 7 I will multiply with e power minus alpha. If I multiply equation 7 with e power minus alpha, left side becomes e into e power minus alpha, and e power minus alpha ಇದೆಯಲ್ಲ, this e power alpha minus alpha again I am multiplying inside, ಒಳಗಡೆ ತಗೊಂಡು ಹೋಗಿದ್ದೀನಿ ನೋಡಿ. h nu n naught e power minus alpha ಹೊರಗಡೆ ಹಾಗೆ ಇದೆ, ಹೊರಗಡೆ ಏನೋ ಟಚ್ ಮಾಡಿಲ್ಲ, ಬಟ್ ಎರಡು ಕಡೆನೇ e power minus alpha ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ಕೋಬೇಕು. ಆ e power minus alpha ನ I have taken inside this sum. ಈ ಸೀರೀಸ್ ಇದೆಯಲ್ಲ, ಸೀರೀಸ್ ಒಳಗಡೆ ತಗೊಂಡು ಹೋಗಿದ್ದೀನಿ. So 1 into e power minus alpha, e power minus alpha, 2 into e power minus alpha, again e power minus alpha, 2 into e power minus 2 alpha. So 3 into e power minus 2 alpha. Again, if you multiply e power minus alpha, so it becomes 3 into e power minus 3 alpha and so on. And this is equation 8. This step gottaita?
Yes, sir. Yes,
What
sir.
I did is, I simply multiplied equations with e power minus alpha on both sides. And right side, what I have done is, e power minus alpha I have taken inside the bracket. A terms idella adru olagade tagondini, so that you are going to end up with equation 8. Next one is, I am going to do this equation 7 minus equation 8. I am subtracting equation 8 from equation 7. So if you subtract, left side ali e minus e into e power minus alpha, capital E is common, so therefore it is capital E into 1 minus e power minus alpha, because I am subtracting. Okay, and then h nu n naught e power minus alpha common ಆಗಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. 1 ಇಲ್ಲಿ ಒಳಗಡೆ ಒಂದು ಟರ್ಮ್ ಯಾವುದು ಇಲ್ಲ, 1 ಯಾವ್ದಿಲ್ಲ, ಹಾಗಾಗಿ ಇಲ್ಲಿ 1 ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. I have 2 e power minus alpha and I have here 1 e power minus alpha. 2 e power minus alpha, 1 e power minus alpha is e power minus alpha. So this is the second term. I have 3 e power minus 2 alpha in equation 7 and 2 e power minus 2 alpha in equation 8. So 3 e power minus 2 alpha minus 2 e power minus 2 alpha, I am going to get e power minus 2 alpha. Okay. So therefore, e into 1 minus exponential minus alpha h nu n naught e power minus alpha ಹಾಗೆ ಇದೆ. This 1 plus e power minus alpha plus e power minus 2 alpha I have already written here. 1 plus e power minus alpha plus e power minus 2 alpha is nothing but 1 divided by 1 minus e power minus alpha. So I am using that. If I use that, I am going to end up with e, capital E into 1 minus e power minus alpha is equal to h nu into n naught e power minus alpha, h nu n naught e power minus alpha ಹಾಗೆ ಇದೆ. The whole summation becomes 1 divided by 1 minus e power minus alpha ಹಾಗೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. Okay, so if you take this 1 minus e power minus alpha right side, you are going to get equation 9. Equation 9 says capital E is equal to h nu n naught e power minus alpha divided by 1 minus e power minus alpha whole square. 1 into e power minus alpha, 1 into e power minus alpha, ಎರಡು ಸೇರ್ಕೊಂಡು multiply ಆಗುತ್ತೆ, ಹಾಗಾಗಿ ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ. Okay, so I repeat, equation 9 gives the total energy of oscillators, whereas equation 6 gives the total number of oscillators. Actually n is total number of oscillators. So expression ಸ್ವಲ್ಪ reverse ಬರ್ಕೊಂಡಿದೀವಿ, n naught by n ಅಂತ. So therefore we have this expression 1 minus e power minus alpha, n naught by n is equal to 1 minus e power minus alpha, that is equation 6. Next, what I want is, I want average energy per oscillator. Average energy per oscillator is total energy divided by total number of oscillators. Okay, so total energy ille ide, previous step alli ide, illade equation number kodu, sorry equation 9 ide nodi, equation 9 ide, equation 9 as per equation 9. Okay, so it is, so n naught h nu e power minus alpha 1 divided by 1 minus e power minus alpha whole square. So divided by n, ಯಾಕೆಂದ್ರೆ total energy per oscillator ಮಾಡ್ತಿರೋದ್ರಿಂದ divided by n ಮಾಡಬೇಕು, ಆ n ಸೇರ್ಕೊಳ್ಳುತ್ತೆ. Okay, n naught by n is nothing but 1 minus e power minus alpha. This is according to equation 6. n naught by n is equal to 1 minus e power minus alpha ಆಗುತ್ತೆ. So therefore ಅದನ್ನ ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ ಒಂದು e power 1 minus e power minus alpha cancel ಆಗುತ್ತೆ. So we end up with e bar, average energy per oscillator, is equal to h nu e power minus alpha divided by 1 minus e power minus alpha. E power minus alpha na denominator ತಗೊಂಡ್ರೆ you are going to get e bar is equal to h nu divided by e power alpha divided alpha minus 1, and alpha is nothing but h nu by kt. So therefore average energy per oscillator e bar is equal to h nu by exponential h nu by kt minus 1, that is equation 10. Okay, hopefully I think you have followed up to this step. Follow ಮಾಡಿದ್ರಾ?
Yes, sir. Yes,
this is a very simple mathematics. Follow ಮಾಡಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಆಮೇಲೆ ಒಂದ್ಸಲ ವರ್ಕೌಟ್ ಮಾಡಿ. ಓಕೆ, ಅಯ್ಯೋ ಏನೋ ಮಾಡಿದಾರೆ ಏನೋ ಬರ್ದಿದ್ದಾರೆ ಅಂತ ಮೆಂಟಾಲಿಟಿ ಇಟ್ಕೊಂಡ್ರೆ just a second pause ಮಾಡ್ಬಿಡ್ತೀನಿ, ಅದು ರೆಕಾರ್ಡ್ ಆಗುತ್ತೆ. So okay, we shall continue. We have got expression for average energy of the oscillator. E bar is equal to h nu divided by e power h nu by kt minus 1, where nu is the frequency of the oscillator. Okay, this is equation 10. Okay, and there is one more derivation which we are not doing. Okay, the number of oscillators per unit volume of the black body in the frequency range nu to nu plus d nu, that is frequency range d nu ಆಗುತ್ತೆ, is n nu is equal to 8 pi nu square divided by c cubic d nu. So there is a derivation of this expression. We shall not bother about the derivation. This n nu gives the total number of oscillators per unit volume of the black body in the frequency range d nu. D nu frequency range ಅಲ್ಲಿ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಅಂತ ತಗೊಂಡ್ರೆ ಬ್ಲಾಕ್ ಬಾಡಿ ಒಳಗಡೆ ಇಷ್ಟು ಆಸಿಲೇಟರ್ಸ್ ಇರುತ್ತಂತೆ 8 pi nu square divided by c cube into d nu. How we are deriving, you don't bother about this. Okay, so therefore this is equation 11. So therefore total energy per unit volume in the frequency range nu to nu plus d nu of the oscillator of the black body is E nu d nu. E nu d nu is nothing but the total energy per unit volume in the frequency range nu to nu plus d nu. Okay, so is given by average energy per oscillator into number of oscillators. Average energy per oscillator into number of oscillators ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ total energy per unit volume in the frequency range nu to nu plus d nu ಸಿಗುತ್ತೆ. So therefore ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ equation 10 ಮತ್ತೆ equation 11 ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು. ಎರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ you will end up with this expression equation 12 E nu d nu is equal to 8 pi h nu cube divided by c cube 1 divided by e power h nu by kt minus 1 into d nu, and this equation is what we call it as Planck's radiation law. Okay, so this is what we wanted to derive. We derived Planck's radiation law, and just I would like to give the information. It is this Planck's radiation law which we have written in equation 12 successfully explains the distribution of energy in the black body spectrum. Okay, so this is what Planck's radiation law, equation 12 represents Planck's radiation law in terms of frequency. Okay, so there is also another way of writing. E Planck's radiation law na wavelength allu kuda baribodu. Okay, that's what I have done in the next step. So frequency nu is equal to c by lambda agutte. If you differentiate, okay, d nu, so differentiation of c is constant, velocity of rate is constant. Differentiation of 1 by lambda is minus 1 by lambda is lambda square into d lambda agutte. But if you take magnitude, so then you are going to get d nu is equal to c by lambda square into d lambda. Okay, magnitude andre we are neglecting the negative sign bitbiಟ್ಟು ಉಳಿದಿದ್ದು ಮಾತ್ರ ತಗೋತಾ ಇದೀವಿ. So therefore d nu becomes equal to c by lambda square into d lambda. So if I substitute this, d nu is equal to c by lambda square d lambda in equation 12. ಇದನ್ನ ತಗೊಂಡು equation 12 ಅಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ nu cube by c cube ಅಂತಿದೆ. Nu by c is nothing but 1 by lambda, so therefore 1 by lambda cube ಆಗುತ್ತೆ. ಈ d nu ಒಳಗಡೆ c divided by lambda square ಇದೆ. So overall ಎರಡನ್ನು ಸೇರಿಸಿಕೊಂಡ್ರೆ you are going to get e lambda d lambda is equal to 8 pi h c divided by lambda to the power of 5 1 divided by e power h c by lambda kt minus 1 into d lambda. Equation 13 is also the same Planck's radiation law but in terms of wavelength. Okay, equation 12 and equation 13 ಎರಡು ಕೂಡ ಸೇಮ್ ಇದೆ. equation 12 ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ ನಾವು, so Planck's radiation law na ನಾವು frequency ನಲ್ಲಿ ಎಕ್ಸ್‌ಪ್ರೆಸ್ ಮಾಡಿದ್ವಿ. ಸೇಮ್ ಅದೇ ಎಕ್ಸ್‌ಪ್ರೆಷನ್ ನ ವೇವ್ಲೆಂತ್ ಅಲ್ಲಿ ಎಕ್ಸ್‌ಪ್ರೆಸ್ ಮಾಡಿದ್ರೆ equation 13 ಸಿಗುತ್ತೆ. So therefore equation 13 also represents Planck's radiation law in terms of wavelength. So therefore it is given by e lambda d lambda is equal to 8 by h c divided by lambda power 5 1 divided by e power h c lambda kt minus 1 into d lambda. So for this purpose we are using d nu is equal to c by lambda square into d lambda. ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಮತ್ತೆ nu is equal to c by lambda ಇದನ್ನು ಕೂಡ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಎಲ್ಲ ತಗೊಂಡು equation 12 ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ we are going to get this expression 13. Okay, so on last conclusion, Planck's radiation law successfully explained the distribution of energy in the black body spectrum. Okay, please remember Planck derived this expression 13 on the basis of quantum picture in which the energy is not continuous, energy is discrete. So either it should be, actually it should be nh nu where n is equal to 0 1 2 3. Substitute 0, either it should be 0 or it should be h nu or it should be 3h nu or it should be 3h nu 4h nu etc. That is one thing. And the emission and absorption of radiation do not happen, okay, so in a continuous fashion, they happen in discrete fashion. So they happen in packets of energy called quantum. Okay, so based on these two pictures he derived this expression 13, and this expression 13 is what we call it as Planck's radiation law. And Planck's radiation law successfully explained distribution of energy in the black body spectrum. Yeah, if you have any doubt you can ask, otherwise I will take another 2-3 minutes and I will wrap it up. Any doubt idre kelbodu. ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಇದೀರಾ ಲೈನ್ ಅಲ್ಲಿ?
ಇದೀರಿ ಸರ್.
Others?
Yes, sir.
Yes, sir.
Okay. Hopefully, I think you have followed this derivation. Nodkole, this is important from the examination point of view. So they will ask you to derive Planck's radiation law. Planck's radiation law means either you can derive in terms of frequency or in terms of wavelength, both are same. For specific ಆಗಿ wavelength ಅಂತಾನೆ ಕೇಳಿದ್ರೆ ಇಲ್ಲಿವರೆಗೂ equation 13 ತನಕ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅಥವಾ so equation frequency ಅಂತ ಕೇಳಿದ್ರೆ equation 12 ತನಕ ಮಾಡಿ ಅಲ್ಲಿಗೆ ಕೂಡ ನಿಲ್ಲಿಸಬಹುದು. Yes, we shall discuss for another 2-3 minutes. Okay, I have written here note. Wien's law and Rayleigh-Jeans law are approximations of Planck's law of radiation. Actually, this Wien's law and the Rayleigh-Jeans law, they are not completely new laws. They are actually approximations of Planck's law of radiation. Okay, and that is what I am showing here. So at shorter wavelength, please remember Wien's law is applicable at shorter wavelengths. I told this long back in the previous class. Okay, so we have a term e power hc by lambda kt here in equation 13. Denominator nalli e power hc by lambda kt anta ide equation 13 ಒಳಗಡೆ. ಶಾರ್ಟ್ ವೇವ್ಲೆಂತ್ ಅಂದ್ರೆ ಅರ್ಥ ಲ್ಯಾಂಬ್ಡಾ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ. ಲ್ಯಾಂಬ್ಡಾ ಕಡಿಮೆ ಇದ್ರೆ ಓಕೆ hc lambda denominator ನಲ್ಲಿದೆ, ಹಾಗಾಗಿ ಲ್ಯಾಂಬ್ಡಾ ಕಡಿಮೆ ಇದ್ರೆ hc by lambda kt would be a bigger number, far greater than 1. Do you agree? There is a lambda term in the denominator. If lambda is small, so therefore this hc by lambda kt should be a bigger number. Bigger number means it is a number which is far greater than 1. So therefore if hc by lambda kt is a bigger number compared to 1, then e power hc by lambda kt is also a number bigger than 1. So therefore I can say in equation 13 ಒಳಗಡೆ lambda ಕಡಿಮೆ ಇದ್ದಾಗ e power hc by lambda kt ತುಂಬಾ ದೊಡ್ಡ ನಂಬರ್ ಇರುತ್ತೆ compared to 1. So what you can do is ಇದನ್ನ neglect ಮಾಡಬಹುದು. You can neglect 1 minus 1 in compared to e power hc by lambda kt. So if you do that, then so you are going to get, if you are doing that, you are going to get e power lambda d lambda is equal to 8 by hc into lambda to the power of minus 5. So exponential denominator ಇದೆ, numerator ತಗೊಂಡ್ರೆ exponential minus hc by lambda kt into d lambda ಆಗುತ್ತೆ. Okay, so this is precisely your Wien's law. So therefore from Planck's radiation law we are able to derive Wien's law just by going to the shorter wavelength region. At shorter wavelength region, lambda is too small, hc by lambda kt is large, so therefore e power hc by lambda kt is also large. So therefore you can neglect 1 compared to e power hc by lambda kt. So ಇದನ್ನ ತೆಗೆದುಬಿಟ್ರೆ ಆಗೋಯ್ತು, ಇದನ್ನ ಬಿಟ್ಬಿಟ್ರೆ ಆಗೋಯ್ತು. ಈ e power hc by lambda kt ನ್ಯೂಮರೇಟರ್ ಹೊರಟೋಗುತ್ತೆ, ಮೈನಸ್ ಅಂತ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಅದು ಮೈನಸ್ ಅಂತ ಬಂದ್ರೆ, so then you are going to get this expression. So e lambda d lambda is equal to 8 by hc lambda power minus 5 e power minus hc divided by lambda kt to d lambda. This is precisely the same Wien's law. You can check back. ನಾನು ಆಮೇಲೆ ಕಳಿಸಿದ್ಮೇಲೆ ಅಷ್ಟು Wien's law ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, ಅದು ಅಲ್ಲೂ ಕೂಡ ಇದೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬಂದಿದೆ. You can check back. Okay. Next, if you go to the higher wavelength region, at higher wavelength region lambda ಜಾಸ್ತಿ ಇದೆ. Lambda ಜಾಸ್ತಿ ಇದ್ರೆ hc by lambda kt ಕಡಿಮೆ ಇರುತ್ತೆ. So therefore the value hc by lambda kt would be far lesser than 1. Okay, when lambda is large, when lambda is longer. So therefore this exponential hc by lambda kt you can express this exponential hc by lambda kt in terms of a series. So if you expand this exponential function in terms of series, you are going to get 1 plus hc by lambda kt plus 1 by 2 factorial into hc by lambda kt whole square. Cube term ಎಲ್ಲ ಬರುತ್ತೆ. Okay, but the thing is, in this series expansion, only the first two terms 1 and hc by lambda kt are bigger terms and the remaining are smaller terms. So therefore if you neglect higher order terms, square, cube, power 4 ಇದನ್ನೆಲ್ಲ neglect ಮಾಡಿದ್ರೆ, you are going to get e power hc by lambda kt is approximately equal to 1 plus hc by lambda kt ಆಗುತ್ತೆ. If you substitute this in Planck's derivation ಅಥವಾ Planck's radiation law, so you are going to get this expression e lambda d lambda is equal to 8 by hc by lambda power 5 divided by hc divided by lambda kt. ಅಲ್ಲಿ +1 -1 ಅಂತ ಬರುತ್ತೆ, ಅದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಇಷ್ಟು ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ d lambda is equal to 8/4 kT into d lambda, and this is nothing but your Rayleigh-Jeans law. So just I would like to conclude that both Wien's law and Rayleigh-Jeans law can be obtained from Planck's radiation law, and I can say that both of them are approximations of Planck's radiation.